Factoring by grouping is a factoring method that sometimes works with four-term polynomials. So we're going to go through this process now. Our first step is to group the polynomial by first terms and last terms. It's very important that we don't do this using parentheses. Parentheses almost always change the meaning of the polynomial, and they make it look as though it's factored, when really all we're doing is making ourselves look at two terms at a time. So don't use parentheses for this step, just underline the terms in groups. The next step is to factor out the GCF of each group. So that means that looking only at the first group, 2x cubed plus 10x squared, I'm looking for the GCF. 2 is the largest number I can factor out. X squared is the smallest power of x, so 2x squared is what I can factor out of these two terms. That leaves me with x plus 5 remaining. And then I go on to the second group. Looking at the group 3x plus 15, I see that I can factor out a 3. It's very important that I put a plus here. These are still two separate added groups. And when I factor out a 3, I have x plus 5 remaining. Now, what makes factoring by grouping work is finding a common binomial. In this case, x plus 5 is a common binomial, and that allows me to do the next step, which is to factor out the x plus 5. I'm going to put the common binomial on the right, and I can see that my other factor is made up of my two GCFs here in purple. 2x squared is what remains in the first term, and plus 3 is what remains in the second term. Only after factoring out this common binomial is my polynomial really factored. Everything up until here is still a sum of two terms. We're now going to try this process on the polynomial 16t cubed minus 8st squared minus 6st plus 3s squared. Again, my first step is to group. I have my first two terms and my last two terms. I now look for a common factor in the first two terms. I can take 8 out of the numbers, and I can take t squared out of the variables. I can't take out an s because my first term does not have an s. After taking that 8t squared out from my first term, I have remaining 2t, and in my second term it is still negative, and all I have remaining is s. Looking at this second group now, a very important thing to note is that the first term of the second group is negative. This convention of GCFs still applies even if it's just the first term of a group rather than the first term of a whole polynomial. So because the first term is negative, I need to factor a negative GCF out of this group, and I want to also remember that factoring out a negative GCF does change the signs of both terms. So I'll factor out a negative 3s, and what that leaves me is 2t in the first term, and then the plus becomes a minus because of my negative GCF. S is all I have remaining in the last term. So remember that taking out a negative GCF does change the signs of all terms. I'm now ready to factor out my common binomial of 2t minus s. I'll write down my purple factor first, which comes from the two GCFs. That's 8t squared minus 3s. And my second factor, which comes from the common binomial, we'll write in black. 2t minus s. It is still correct to write these in the other order, but what we'll find when we go to check something like this, and remember that we always check by multiplying, we'll find that when we FOIL this back out, the terms will come out in the same order if we put the common binomial second. So to check this using FOIL, my first term is going to be 16t cubed, coming from 8t squared times 2t. My outer term is going to come from 8t squared times minus s, so it's going to be minus 8t squared s, which we would of course write in alphabetic order as 8s t squared. My inner term comes from negative 3s times 2t, so that's going to be negative 6st. And my last term comes from negative 3s times negative s. Negative times negative is positive. That last term is positive 3s squared. Comparing this to my original polynomial, I can see that I do have the exact same expression, and therefore the factorization worked. Going on to our next example, if we start this the same way that we started the last two, that would be by grouping first two terms with last two terms, then I would see that I have nothing to factor out of the first group, so maybe I would try factoring out a 1, leaving me with 3x cubed minus 7. And out of the second group I could factor out an x, which leaves me with 3 minus 7x. So I can see by looking at this that I do not have a common binomial, and therefore this approach didn't work. Sometimes if you don't get a common binomial, it means that the polynomial can't be factored by grouping. But other times, as is the case here, maybe we just need to try a different order for the terms. And now that I look at it again, I can see that these terms really weren't in descending powers. So I'm going to rearrange these into descending powers first. So we put the terms in descending powers. If we have more than one variable in the polynomial, then we just need to put it in descending powers of one variable. In this case, we have only x, so we put it in descending powers of x. Now we can group by the two highest powers and the two lowest powers. And if I take an x squared out of the first group, then that leaves me 3x minus 7. And looking at the second group, I can see that I don't have any common factors. With factoring by grouping, this is the only time that it still is very important to factor out a 1. If I don't write the plus 1, then it's much more confusing in the next step, in which I factor out the common binomial. It's much more confusing where all these terms come from. By writing the plus 1, I can now see that my blue GCF factors create the terms for the first factor, which is x squared plus 1, and that my black common binomial becomes my second factor, 3x minus 7. So reordering the terms can be helpful. However, if descending powers doesn't do it, then nothing else will. If it is possible to factor the polynomial by grouping at all, it should work if the terms are put in order of descending powers of one variable. Finally, we're going to look at this example here. 2x cubed minus 3x squared, group those two terms, minus 4x minus 6. The terms are already in order of descending powers. I can take x squared from the first group, and that will leave me with 2x minus 3. And from the second group, I want to remember that if the first term is negative, I factor out a negative. So I will factor out a negative 2 here. And I also, very important, need to remember that factoring out a negative number changes both signs. So that becomes positive 2x, the negative 6 becomes positive 3. This time we do not have a common binomial. And it's not something that we can fix by reordering the terms or by factoring out a positive instead of a negative, because both terms don't have different signs, only one term has a different sign. So if there's no common binomial, and there's no way to fix that by reordering the terms or being more careful about what you factor out as your GCF, or being more careful about your signs as you factor it out, this means that factoring by grouping does not work. Note that it does not necessarily mean our polynomial is prime. It's possible that this polynomial could be factored by a different method that we don't know yet. But this does definitely mean that factoring by grouping does not work. There's no way that we can force a factorization out of it from a result like this. That common binomial is absolutely necessary to get from this form that we have here, which you can see is still a sum or difference of two separate terms. It's not fully factored yet. There's no way to get from this form to a fully factored form without having that common binomial to pull out of the whole thing.